Hello, and today we're going to look at projectiles as vectors from your A-level mechanics syllabus. This will be a very short video. We're going to look at two examples. Let's get stuck into the first one. A particle is projected on a horizontal plane with an initial velocity of 40 meters per second at an angle of alpha above the horizontal, where tan alpha equals 3/4. There's a lot of words that are very confusing in there, but the important thing to note here first is tan alpha equals 3/4. That tells us quite a bit about the question, in fact. So what we're going to do is think about SOHCAHTOA and how that relates to tan alpha equals 3/4, and we're going to draw a small diagram to represent it. Now, if tan alpha equals 3/4, and we draw that as a diagram, we're going to draw a right-angled triangle, as I'm doing here. The 3/4 can be broken up into 3 and 4. Now, since we know that tan is opposite over adjacent, that we can see in TOA, then I know the opposite side of this triangle measures 3, and I know the adjacent side measures 4. Now, we can use Pythagoras' theorem to work out the hypotenuse, but hopefully, as A-level students, it should be obvious for you. It should be 5. And I'm just jotting it in there, 5. From there, we can also work out sin and cos. Cos is adjacent over hypotenuse, so obviously from the triangle, that's going to be 4 over 5. And sine is opposite over hypotenuse, which again from the triangle should be 3 over 5. Sometimes these ratios will be useful, sometimes they won't be. But if you see tan alpha equals 3/4 or something similar, you should always start by doing that. Now, to relate this triangle into a more practical example, if we look at the triangle and we have a velocity of 5, think of the hypotenuse as your velocity. So a length of 5 gives us a velocity of 5, which means if we have a velocity of 5, we know the vector for a velocity of 5 is 4i plus 3j. The 4 and the 3 are taken directly from the triangle, 4 long and 3 up. So a vector of 4 long and 3 up gives us a velocity of 5. Now our question is giving us an initial velocity of 40. I'm going to relate that to the little triangle we've just drawn. Now, hopefully you're all familiar with the basic times tables. 5 times 8 gives us 40. 5 times 8 to give us the 40, which means that if a velocity of 5 has a vector of 4i plus 3j, then a velocity of 40 should be 8 times bigger. And 4 times 8 gives us 32. 3 times 8 gives us 24. So our required vector is 32i plus 24j. To break this up into its components, if you like, the horizontal component, ux, is 32, and the vertical component, uy, is 24. We can also go a little step further by drawing this as its own separate triangle. This part isn't always necessary, but sometimes easy to check your answer by using Pythagoras' theorem. So if we stick our numbers in it, we should have a velocity of 40, a horizontal distance of 32, and a vertical distance of 24. And again, you can use Pythagoras to check that's correct, but it is in this case. I kind of over-explained this question. But if we look at question 2, a particle is projected with a velocity of u equals 3i plus 5j meters per second. Find the initial speed of the particle and its angle of projection. This question is the reverse of the previous one, where we're given the vector, but we need to find the speed. We need to turn the vector into a speed. If you're clued in, you already know how to do it. But if not, worry not. It's very easy. So I'm starting again with the little triangle. 3i gives me the distance along the bottom, distance of 3. 5j gives me the distance up the side, a distance of 5. And again, I can use Pythagoras' theorem to figure out u. So u, using Pythagoras, is going to be the square root of 3 squared plus 5 squared. And here we go, 3 squared plus 5 squared. Now you can leave your answer in exact form as root 34 meters per second, or you can round it up to something appropriate like 2 decimal places. So 5.83 meters per second in this case. Your question will usually specify how to use it. To find the required angle of projection, think about where the angle is in the diagram, and then use SOHCAHTOA. So in this case, we've got the opposite and the adjacent sides, and that should be a tan. So tan alpha, which is opposite over adjacent, equals 5/3. Inverse tan to find alpha. So alpha equals tan to the minus 1 of 5/3, or alpha is about 59 degrees. Not too difficult. Just kind of follow these examples when you're doing your exercises. And do remember, of course, to click like and subscribe if you find this useful.